Thank you so much for joining this lesson. We're going to discuss the Kisumu East Mathematics Association. That is the Kema 2025 examination. This is the exam which was done in May 2025. So we're going to look at the questions bit by bit so that we may see what the examiners expected in this paper. Simplify in number 1 the expression 8 out of 2 minus the root of 3, then plus 2 divided by 2 plus the root of 3, leaving your answer in the form a plus b the root of c, where a, b, and c are integers. So we must ensure that at the end of the day, a, b, and c are integers. So I want to advise all students who are following this platform that whenever you get a surd which is having two parts like this one, just treat it as a normal fraction, whereby when you treat like a normal fraction, then you will be having the denominator now being the LCM, 2 minus the root of 3 into 2 plus the root of 3, that way. So now we take the LCM and we divide by the first denominator, which is 2 minus the root of 3, which means 2 minus the root of 3 will cancel. Then what we are getting from that division now of the LCM divided by the first denominator, then should multiply the numerator. So we'll be multiplying 8 by 2 plus the root of 3. Then we have plus, we divide again the LCM by the second denominator, which is 2 plus the root of 3. So 2 plus the root of 3 cancels, and we'll have 2 multiplying 2 minus the root of 3. That way, after this step now, we can expand the numerator, whereby 8 by 2 becomes 16 plus 8 the root of 3 plus 4. Then we have to minus 2 the root of 3. That way. Remember, now we are having the denominator, and when you look at the denominator and you examine it very well, you shall realize that this is a difference of two squares which has already been factorized. Therefore, we are supposed to expand it. Remember, according to the quadratic identities, when you have a difference of two squares, let's say you are having x squared minus y squared, the simplified format of this should be x minus y, x plus y. This is a quadratic identity, which is called the difference of two squares. So we are having the simplified right-hand side. So we need to expand for us to get it in this format. And therefore, it means we should take 2 squared, which is 4, then minus the root of 2 also squared, which is 3. Yeah, the root of 2 squared is 3, that way. So when you square root 3, you get 3. This means now, after subtracting at the denominator, we'll be getting 1. But before then, let's now combine like terms on the numerator, whereby 16 combines with 4 to give us 20. Then after writing 20, now we should again look at 8 root 3 minus 2 root 3. That will give us 6 root 3. So we add 6 the root of 3. You see, this one now is being divided by 1. And you know very well that when anything is divided by 1, the value just remains as it is. So the most simplified answer here is 20 plus 6 the root of 3. That way. So we are through now with the simplification, and according to the demand statement now, the question is in the format that the examiners needed it. If there were no further instructions of the format we would leave it at, you can see that 2 is common in this question, whereby we could still have multiplied or factored out 2 to remain with 10 plus 3 the root of 3, such a thing. But in this case now, we didn't want it in that format. It is already final. Number 2. Remember, ladies and gentlemen, to subscribe to this platform and also to share the link with your friends. A rice blender mixes two types of rice, A, which costs 160 Kenya shillings, and B, which costs 180 Kenya shillings. She sells the mixture at 187.60 Kenya shillings, or rather 187 shillings and 60 cents, thereby making a profit of 12%. Find the ratio A is to B at which she mixed the two types of rice. This is a very good question from mixtures, ratios, and proportions. So check here. When this business lady sells the mixture at 187.60 Kenya shillings, there is a profit of 12%. So this means the whole of this amount is 112%. This is equivalent to 187.60 Kenya shillings. What about 100%, which is the cost price of a kilogram of rice after mixing? Then this will be 100 by 187.60 out of 112. So that we may know what was the cost of 1 kg after mixing for this particular blend of rice. 100 by 187.60 divided by 112. This gives us exactly 167.5. 167.5. So after mixing, this lady realized a mixture which was costing 167.5 and of course 50, Kenya shillings. Then now we should use these for us to get the ratios in which the two brands were mixed to get a blend. Okay, the first, we can say A kilograms of the first type at 160. So 160 times A kilograms. Then we add 180 shillings for the B type. Now, when this is divided by the number of kgs which have been mixed, we have mixed A kilograms for the first type and then B for the second type. Now, this is going to give us 167.50. So at this point now, we can do a cross multiplication where we should get 160A plus 180B. This is equivalent to 167.5A and also 167.5B that way, because AB multiplies this part. At this point now, we can group terms here. For the S, we need to take 167 because I'm taking the S to the right and I subtract 160 for me to get 7.5A. Then on the left-hand side, I take 180 and I subtract 167.5. This is giving me 12.5B. So for us to remain with A, on the right, we are supposed to divide 12.5 by 7.5. Check. It's already having a B here over 7.5, which had multiplied A at this point. So this means, again, for me to remain with 12.5 over 7.5, I have to divide through by B. So that A now is divided by B that way. So A over B is the same as, when I divide this by 7.5, you see now I'm getting a 1 2/3, which means 5 over 3. Now with this, we are supposed to know that the ratio is already simplified and in fraction. So we can now write it as a ratio instead of a fraction. If A over B equals to 5 over 3, then A is to B is 5 is to 3 that way. So that's how we get the ratio into which the two brands were mixed to get the blend. It's also good for you to know that alternatively, this can be worked out very simply by saying there is type A, there is type B. Type A is costing 160, right? Type B costing 180. When these two have been mixed, we are arriving at 167.5. Therefore, now with this, we are supposed to subtract now both values from the cost price of 1 kg. So 160 and 167 should be subtracted, and this will give us 7.5 at this point. Then 180 and the same value should also be subtracted, and this is going to give us 12.5. So the ratio in which A and B have been mixed is 12.5. We simplify now because it is to 7.5, which gives us 5:3. So you can just compare the ratios in a very simple and quick way and get the answers. The method is already approved. Let's look at number 3. Use completing square method to find exact roots of the equation, or rather to solve for x in the equation 9x squared minus 21x plus 10 equals to 0. Ladies and gentlemen, remember to subscribe to our platform so that we may continue updating you and giving you our current trends in the prediction of national exams, both the KCSE for those in 844 and also for the KJCR for those in the CBC. Let's look at the completing square method of solving quadratic equations. The first thing that we shall do, if the coefficient of x squared is not 1, we start by making it 1. And that is because the coefficient is 9 in our given equation. We divide it through by 9. So x squared minus 21 over 9 x plus 10 out of 9 equals to 0 over 9, which is just 0. After this first step, now we are supposed to take the constant to the right-hand side. X squared minus, 21 divided by 9 becomes 7 over 3. Yeah, because 3 can divide by 3, 7 by 3, 3x. Then this one now, we take negative 10 over 9 to the right-hand side. Now with this, we usually say that we make the left-hand side a perfect square. And what is a perfect square? A perfect square is the one in which when we take the value of b squared, we should be in a position to when we take the value, I want to relate all the constants in a perfect square. Assuming that an expression is a perfect square, I want to write the general formula for you. Assume ax squared plus bx plus c is a quadratic expression, which is a perfect square. Then it means for these particular terms, when we take the value of b squared, we should be in a position to get 4 multiplied by ac. Yeah, 4 multiplied by ac. Therefore, there is a constant c, which can now be calculated simply by taking, for us to get, and remember here, the value of a is just 1. We have already made the value of a 1. So a can even, because the value is 1, it can even cancel out from this, such that now we'll say the value of c will be given by, when we take b squared and we divide it by 4. B squared over 4. And b squared over 4 is still the same as b out of 2, everything squared, because 4 is a squared 2. I hope you're getting me there. 4 is a squared 2. So in a perfect square, where the coefficient of a is a 1, then the value of a constant that will help us to realize a perfect square on our left-hand side, this constant is given by the value of b out of 2 squared. Therefore, do we know the value of b in our expression? Yes. The value of b is negative 7 over 3. Now, this one should be divided by 2. Then we square. We realize we are getting a negative 7 over 6. Then now squared. So we get 49 out of 36. Therefore, I get back to my expression now, and I continue now with my working, such that I'm having x squared minus 7 out of 3 x plus 49 over 36. This is the same as negative 10 over 9 plus the same constant. Yeah, 49 over 36. Then now with this, we can talk of now factorizing the left-hand side. Now, for us to factorize a perfect square, we take the square root of the first term, which is x, the sign that follows, which is a minus, the square root of the constant, which is a 7 over 6. Now, this one squared is the factorized format of the perfect square that we are already having. In case we expand x minus 7 over 6 squared, we shall obtain the perfect square above, which is x squared minus 7 over 3x plus 49 over 36. Now, this is the same as, we also work out negative 10 over 9 plus 49 over 36. And I'm getting 1 over 4. At this point now, we can talk of obtaining square root. I hope you are listening to me carefully. Obtaining the square root for both sides now. When we take the square root for the left-hand side, we shall get x minus 7 over 6. And on the other side, the square root of a quarter is either plus or minus half. Plus or minus half. Now we can go to the last step, which is obtaining the value of x. For us to get x, now we should be able to relate very well and take the first option as x equals to, the first option on the square root is a half. Then we add 7 over 6. Or x can also be, the other option of the square root was negative half. Then we add 7 over 6. Because when 7 over 6 is taken to the right, it shall be added. It's already negative on the left. So it shall be added. So the first value of x is either 1 and 2 thirds, or the value of x is equal to 2 thirds. So that's how we work out such a problem. Thank you so much for following up. Remember to subscribe. Remember to comment. Let's know where you are following us from. Let's know whether you are learning something from a Shifting Grades Online School. Number 4, a question on trigonometry. Actually, trigonometry 3, whereby we are dealing with trigonometric identities. Solve the equation 16, the cosine squared of x, plus 8, the sine of x, minus 17 equals to 0 for the range of x being between 0 and 180. Now with this, we need to realize that there is this trigonometric identity that says whenever we have the sine squared of an angle theta plus the cosine squared of the same angle, we get 1. And from this understanding, then we can say cosine squared of theta can also be expressed as 1 minus the sine squared of theta. We make cos squared theta the subject. And at that point, we can apply the same in the first term, whereby we shall have 16. And instead of cosine squared of x, now we shall have 1 minus the sine squared of x, then plus 8, the sine of x, minus 17 equals to 0. When the equation is at this level now, remember the first term can still be expanded. 16 minus 16 sine squared of x plus 8, the sine of x minus 17. This is equivalent to 0. Yeah, this is equivalent to 0. At this point now, we can let sine of x to be another unknown. Let it be something like T or Y. Any letter of the alphabet can be used in such algebra. So 16, and we will be combining terms, So 16 minus 16 t squared plus 8t minus 17, this is equivalent to 0. Let me now group some terms so that we can, actually, I can take all the terms to my right, so that I begin with 16 t squared minus 8t, small letter t. Then after this now, I'll be having 17 becoming positive and 16 becoming negative, such that we have 17 minus 16, which gives us exactly 1. That way. In such a case now, we should proceed, because we have remained with a 0 here. We solve it quadratically now. There are very many options of solving a quadratic equations, including the use of a completing square method that we have used up there. But because we have already revisited the completing square method, allow me now use the quadratic formula. In this equation, we are having A as 16, B as -8, and C as 1, a positive 1 for this case. Now with this, we should know that the value of X generally now, whereby X has been the general unknown in the quadratic formula. I'll use X, but remember we are solving for T. So that means instead of X, actually, we can say according to the quadratic formula, T will be given by the negative value of B, then plus or minus the square root of B squared minus 4AC, then everything should be divided by 2, the value of A. Therefore, we can now have negative the value of B, which is already negative. So you're supposed to be very careful in such a substitution. Negative, the value of B, which is already a negative. So negative, -8. Then I add or subtract the square root of -8 squared minus 4. The value of A is 16 multiplied by C, which is 1. Then I divide everything by 2 multiplied by the value of A, which is 16, that way. So this will give us the values of T, or the value of T. The value of T will be given by, let me do another step here. Remember, 8 becomes positive now. Then we add or subtract the square root of 64 minus 4 into 16. So minus 0. The square root of 0 is just 0. Minus 0 that way. This is out of 32. Out of 32. So the value of T is 1. Because whether we add or subtract 0, 8 remains the same. Therefore, we shall be getting T as a quarter. If T is a quarter, then we should be able now to say we had let the sign of X to be T. Sign of X to be T. After sign of X was let to be T, that is why this becomes 8T. And this becomes 16T squared. So now it is the sign of X now, which is a quarter. And if the sign of X is a quarter, then we can get an acute angle such that we need the sine inverse of a quarter first. Let's get a quarter. Sine inverse of a quarter. So I write shift sign 1/4. This gives me 14.48. 14.48. So now we are working with an acute angle of 14.48, but now the specific values of X can be numerous depending on the range. Because sin x is a positive value, a quarter was positive, then we need to say that the values of x are supposed to be 14.48 degrees. And we proceed. The angles are many. In this case, now we should talk about the unit circle. Let me just take you back to the unit circle. That when I draw the unit circle this way, remember the angles are supposed to be measured from the x-axis and in the anti-clockwise direction. In this case, now we are having the first quadrant whereby all trigonometric ratios are positive. The second, whereby only sines. The third, whereby only tangents are positive. And the last one, the fourth quadrant, whereby only cosines are positive. Therefore, we need the value of 14.48 in the quadrants where signs are positive. And where are signs positive? In the first and second quadrant. Therefore, in the first quadrant, we just pick the value of the theta. And that is why we say the first angle is 14.48. But in the second quadrant, to measure an angle there, then you need 180 minus the value of theta. In the third, you need 180 plus the value of theta. And finally here, we need 360 minus the value of theta. So that's how we place the acute angle that we are dealing with in the respective quadrants. With this knowledge now, we need to get 180 minus this value, whereby I'm getting 165.52 degrees once again, because the ratio is between 0 and 180, then these are the only angles that are going to satisfy the equation above. Remember, there can be many other angles satisfying the same equation if it were not for the range. And you can see such questions in our platform, Shifting Grades Online School. Number 5 now, yes. Solve for n in the equation n, the logarithm of 625 base 5 plus 2, the log of 2 base 5. This is equivalent to 2/3 the log of 1,000 base 5. So for us to get the value, of n, then we need to apply some laws of logarithms, which are eventually going to be numerous. From the first term here, which is n, log of 625 to base 5, we are supposed to know that this is n, the log of 5. Then now, the log to base 5, then 625 can be written as 5 power 4. Yeah, 5 power 4. Then plus 2, the log of 2 to base 5. And this is equal to, let's talk about, in this case now, in this case we can talk about, can we also express, okay, we can apply the third law, which says when we have n, the log of a, this can be solved as log of a raised to power n. Therefore, we need to talk about the log to base 5, of course, but now of 1,000 power 2/3. So 2/3 becomes a power. That's what I want you to know. 2/3 becomes a power. Now, I want to apply the same law on the first term. The same law on the first term, such that power 4 now drops here. So that we have 4n, the log of 5 to base 5, plus, I can apply the same law here, whereby I'll be having the log, this becomes 4, because of log of 2 power 2, because 2 becomes a power here. I have applied the law interchangeably in the first two terms. This is the same as, now we apply some indices. And we talk about the fractional law of indices, whereby we are having 1,000 power 2/3. This means we take the third root of 1,000, then now we square everything according to the law of indices that says when the power is a fraction, a power m over n, this can be taken as nth root of a power m, nth root of a power m. So this is the law I'm applying. This one is the law that I'm going to apply. So the third root of 1,000 is 10. Then now I square 10. You see, I'm getting 100. Therefore, I'll be having the log to base 5 of 100. That part has been sorted now that way. Now, at this point, I'm also going to employ a law that says when we have the log of a number to the same base as a value of 1. And if this is true, that the log of any number to the same base is 1, then the whole of this value, the whole of that value now becomes 1. And so we'll be having 4n times 1. So it remains the way it is. This is equal to the log to base 5 of 100 minus the log to base 5 of 4. So 4n equals to, on our right-hand side, we can apply the second law of logarithms. You see, the second law of logarithm says, I'll be listing all the laws. The second law of logarithm says that when we are having the log of a minus the log of b, this can simply be solved by log a divided by b, as long as the bases are the same. And that is the case in our working here. Then the log to base 5 of 100 over 4. You know, at this point, we'll be having 4n equals to the log to base 5 of 25. At this point now, everything is becoming clear that we are almost headed to the answer. Look at this now. So I take now the next step on my next working space, whereby 4n becomes the log to base 5 of 5 squared. If this is 5 squared, then we go back to our third law here, where we shall say we need 4n equals to 2, the log to base 5 of 5. The log of 5 to base 5 is 1. That means the log of any number to the same base is usually equal to 1. That law, I have written it very well here. The log of any number to the same base equals to 1. And if that is so, then we'll be having the value of 4n being equivalent to 2. If 4n equals to 2, then it means the value of n can be found by saying that n equals to 2 over 4. And n simplifies to half. This can also be written as 0.5, a decimal. So that's how we work out. It's a very interesting equation, a very interesting logarithm equation. All right, we can check our number 6 now. You can see that number 6 is a question on binomial expansions. Binomial expansions. I want to train learners so that they may not struggle so much to memorize things which are not essentially supposed to be memorized. Or rather, when given some of these questions like what you're having here, expand 1 minus a half x raised to the power of 8 up to the third term, we need first of all to list the binomial coefficients of power 8. And where are these binomial coefficients of power 8? They are found in the 4-figure tables. So if I go to my files and open the 4-figure table, I'll be able to read all the coefficients of power 8 or any other power. Therefore, opening this, then we go to the last pages, we'll be able to get the powers of binomial coefficients, all of them. All the binomial coefficients are here. So if we can see them here, then we can go directly to the power of 8. And this is where the powers are. The first term should have a coefficient of 1 all the way to 1 again. So those are the powers of 8. But now we need it up to the third term, which means we just need 1, 8, and 28. 1, 8, and 28. If we were expanding fully, then we would have obtained the 9 coefficients for power 8. 1, 8, 28. So we need 1, 8, 28. That way. So in the first term, 1 assumes the whole power 8, and negative half x assumes power 0. Remember, it is negative half x, not just half. In the next term, 1 takes up power 7, and negative 1 over 2 x takes up power 1. And in the third term, 1 is going to go down to power 6, as negative half x assumes power 2. So the powers of 1 begins from 8 and continues to descend all the way to power 0, as the powers of negative half x begin from 0, then start to ascend all the way to power 8. So if there was a continuation, then we would have continued with such a trend. As 1 decreases in the powers, negative half x increases. But at any given term, you should know that the powers must be totaling to 8. 0 and 8, 7 and 1, 6 and 2, such way. We would have gone to 5 and 3, 4 and 4, like such. At this point now, allow me expand, whereby 1 power 8 is 1, and anything power 0 is 1. Therefore, from the first term, we'll be having 1 times 1 times 1 again. Therefore, we are getting 1. Then in the second term, anything power 1 remains the way it is. Therefore, we are having 8 times 1 power 7 is just 1. 8 times 1 multiplied by negative half. So this gives us now negative 4x that way. Then now in the third term, I'll be having 28 times 6 power 1, which is just 1, then negative 2. Negative 1 over 2 x squared. We'll be getting positive a quarter x squared. So we have 28 multiplied by a quarter. This is 7 x squared that way. So that is the expansion up to the third term. It would have continued, but we have to follow the instructions. Yeah, we're supposed to follow instructions very carefully and up to the latter that way. After this expansion now, we are advised in part B to use the expansion in A above to approximate the value of 0.995 raised to the power of 8. So we are supposed to equate these values, 1 and negative half x. Remember, this is power 8, so we equate it to 0.995 also power 8, whereby because the powers are the same, then we can agree that these bases are also the same. Equal, that is 0.995 that way. If the powers are equal, the bases are also equal. Therefore, at this point now, allow me have half x on my right, where it shall become positive, then 1 minus 0.995, and this gives me 1 out of 200. Yeah. So can we get now the value of x? Yes. by dividing through by 2. Okay, multiplying through by 2. Remember, this is a half, not a 2. So we can't divide through by 2. Instead, we multiply by 2. So 1 over 2x. To remain with x, we should multiply here by 2 and also by 2 here. So x becomes 1 over 100. Yeah, x becomes 1 over 100. And 1 over 100 is the same as 0.01. That way. So now that we have the value of x, we can substitute it in our expansion for us to get the value that we need. 1 minus 4, instead of x, 0.01, plus 7, instead of x, 0.01, but now squared. So with this, we can key into the calculator directly. Plus 7 into 0.01 squared. This is going to be 0.9607. Yeah, 4 significant figures. So that is the answer according to the working. So that is it. Thank you so much for following. I would remind you to subscribe to the platform and also to share with your friends. Looking at number 7 now, the unshaded region on the Cartesian plane satisfies the inequality y greater than or equal to negative half 1.5 x plus 5.5. Then we are also having a y less than half x plus 3.5, and also y less than 1.5 x plus 1.5. So we have the inequalities already plotted. We can see the region they satisfy. Looking at the demand statement, we are instructed to find the minimum value of the minimum value of x plus 2y for the integral coordinates of r, xy lying in the shaded region. The minimum value. So we are supposed to minimize instead of maximizing now. We minimize. This is called optimization, remember, in linear programming. Therefore, we are going to look at the least value, or what will give us the least value of xy if we consider the values in the shaded region, and that is the bottommost part, which is lying within complete lines. Remember, if these lines were incomplete, we would not have picked this value. So the value must be the lowest value and lying within complete lines. Therefore, this is going to be 3, 1. So the coordinate of r is 3, 1. And now for this value, then we need 3 plus 2, the value of y, which is 1. So this is 3 plus 2, which is 5. So the minimum value of x plus 2y is 5. Yeah, that way. So that's how a student was supposed to approach such a simple question. Are we together in number 8 now? The transformation represented by the matrix 2n minus 3n, 2.5n, transforms a square whose area is 52 meters squared onto another square whose area is 1352 square meters. Find the possible values of n. So n will have possible values. N shall have possible values, and we shall look at those possibilities. Let us first understand what it means by transforming a certain object into an image. That means when we relate the area of the image and that of the object, we'll be able to get area scale factor. So the area scale factor here is 1352 out of 52. And this is going to be 26. So we have area scale factor of 26 in this transformation. Something else that you're supposed to know is that during a transformation by a matrix, area scale factor is usually equal to the absolute value of the determinant of the matrix. And therefore, the area scale factor that we are getting here is equal to the determinant of the matrix of transformation. Therefore, we ask ourselves, how do we get determinant of a matrix? Product of elements in the leading diagonal, this way. That is called the leading diagonal. The diagonal running from top left to bottom right. Then minus the product of the elements in the other diagonal, this one. Therefore, we say 2n multiplied by 2.5 n minus n multiplied by -3. This one is supposed to give us determinant, and the determinant is equivalent to 26, that way. So when I multiply 2 and 2.5, I'll get 5. The value of n now becomes squared, minus n multiplied by -3. You know, this is a -3. So when I subtract a -3, it changes to a +3n. This is equivalent to 26. And this means our equation can now be solved using the completing square method or any other method of solving quadratic equations. So the first thing will be we divide through by the coefficient of n, so that n squared is now having a coefficient of 1, 26/5. That way. So I'm dividing by 5 all through. After that, we can proceed with our solution. Now, in this case, now I'll be talking about n squared. Then I add 3/5 n, then plus a constant here, such that the left-hand side becomes a perfect square. This constant shall be 3/5 divided by 2, then I square. So 3/5 divided by 2 becomes 3/10. Then squared now, I'll have 9/100. This is equal to 26/5 plus the same constant, 9/100. At this point now, you can allow me to factorize the right-hand side, the left, sorry. Factorizing the left means taking the square root of this part, the sign that follows, the square root of the constant here. Squared equals to, now I take 26/5 and I add 9/100. 26/5, 9/100. This gives me 5 and 29 out of 100. So that's the value of n. Okay, I take square root to both sides. N plus 3/10 equals to, I take square root now for both sides. So square root for both sides gives us 2 and 3/10, sorry. 2 and 3/10. Yeah, 2 and 3/10. But now, this value of the square root on my right-hand side can either be plus or minus. So we have two options on the right-hand side. The value of n will be given by, when I take 2 and 3/10, I subtract 3/10, or the value of n equals to -2 and 3/10 minus 3/10. The first option becomes exactly 2 because of 3/10 minus 3/10. Then the second option becomes -2.6. That way. So I'm having the two values of n, the two possible values of n. I would like to emphasize this. Let learners know that the knowledge on quadratic equations and expressions is very important. You don't need it for the topic only. It is usually applied broadly, actually. So you can see how we have applied here. We had applied it in a previous question. I think I should take you back a little bit. We had applied it somewhere here. We were doing trigonometry, but we found ourselves solving a quadratic equation. And there is now a time whereby it was the quadratic equation itself. So let us be exposed to quadratic equations by all methods, so that whether we need to solve it or we need to apply it, we are still conversant. I'm now in number 9. Owino digs a pit latrine for a number of days. He dug 2 meters on the first day. For him to complete the required depth of 250 meters within the scheduled time, he had to dig 1.5 times the length of the previous day. Find the number of days Owino worked. Okay, now check this. Look at this. We are supposed to know that this is a sequence question, or other sequences and series. Now, on the first day, he dug 2 meters. So this now becomes our first length, which is first term, 2 meters. Then he needs to dig up to a total of 250. So 250 is not any other term, but sum of a given number of terms, which is now totaling to 250 meters. So he should dig until the total length totals to 250 meters within a given number of unknown days. Then now, how is he digging in the previous, in the successive days? After digging today, tomorrow's length shall be 1.5 times the length of the previous day. That means for us to get the next value, we will be multiplying the previous day's depth by 1.5. So we are having a common ratio, which is a 1.5. 1.5. So with this now we can say this type of a progression is now arithmetic. It's not arithmetic, sorry. It's now geometric, simply because we are not having a common difference being added. We are having a common ratio that is multiplying all the values. Therefore, sum of n terms is usually given by the first term into, we take r power n, then we subtract 1, divide by the value of r minus 1. That is the formula for the sum of a given number of terms when the progression is geometric. With this knowledge, now we can say 250, which is the sum of all the lengths, equals to the first term, which is 2, into r 1.5 minus 1. And we divide everything by 1.5 minus 1. You see now I'm having 250 equals to 2 into 1.5 power n minus 1 out of 0.5. So now we are getting the value of n. So 2 divided by 0.5, 2 divided by 0.5 is going to be 4. So we have 250 equals to 4, 1.5 power n minus 1. We can divide through by 4, 250 over 4. This gives us 62.5 equals to 1.5 power n minus 1. Now 1 can be taken to the left where it becomes positive. Talking of 63 now, 0.5 equals to 1.5 raised to power n. And now we can apply logarithms. So we introduce logarithms on both sides of this, such that we are talking of the log of 63.5 equals to the log of 1.5 power n. So I will take you now back to the third law, which says we can drop the power here and have the log now of 1.5. This is equivalent to log 63.5. To remain with n, we take the log of 63.5 divided by the log of 1.5. And this will give us 10.4. 24, that is 10.24, which means for Owino to complete this work, he has to work for 10.24 days. And now this means 10 days will not help him to complete 250 depth. He has to wake up for the 11th day because of this fraction here. So the number of days now are going to be 11 days. There are some cases logically, when you are rounding off, you round to the next value, regardless of the value after the decimal point. People might think that 10.2 cannot be increased, 10.2 cannot be increased to 11. But logically, Owino is going to wake up for the 11th day for him to finish up the work. So 10 days will not be enough. All right. Taking you now to number 10 of this. The figure below is a sketch of a region bounded by the curve. O's equation is y equals to negative x power 2 plus 25. And the line which is y equals to negative 5x plus 25. Find the coordinates of P. Look at P, where it is. And again, we also told to find the exact area of the shaded region. We can see the shaded region now. The region between the line and the curve. It is good for you to know as for us to get the coordinates of P, you know that is the point of intersection between the line and the curve. So we can equate the two sides. But again, should I let you know, just for your information, that they are intersecting at the x-axis, which means we can simply find the point where this line is cutting the x-axis. And where it cuts the x-axis, the value of y is usually 0. So where this line is cutting the x-axis is the coordinate of P. In other words, we find the x-intercept of this line. So 0 instead of y, negative 5x plus 25. So 5x can become positive here, equals to 25, so that the value of x is just 5 after dividing through by 5. If the value of x is 5, then why don't we say that the coordinate of P now is 5, 0, that way? Yeah, simple. People can also say because it is the intersection of the two functions, then we can equate negative x, or we can equate negative 5x plus 25 being equal to the negative x squared plus 25. So you see, 25 will cancel one another. And now x squared minus 5 will be equal to 0, minus 5x. So that factor out x to remain with x minus 5 equals to 0. This alternatively, getting the coordinate of P. We can also say that at this point now, we can have x equals to 0 or x minus 5 equals to 0. So x equals to 5. According to where the position is, the value of x can only be 5 because we are not at the origin. We are not at the origin. That is the truth. We are not at the origin. Find the exact area of the shaded region. Therefore, I'm going to get the area such that for this particular curve, we need to integrate from 0 to 5 so that we get the area between the x-axis area between the x-axis, 0.0, 0.5, and the curve. All that area from the curve all the way. That area will be gotten by integrating the curve from 0 to 5. So let's find the area between the curve, the x-axis, and also the y-axis. So we shall integrate now. From 0 to 5, the function negative x squared plus 25. This is happening with respect to x. Yeah, with respect to x. So now we can now find the value, negative x power 2. The power increases to 3. And now we shall have negative x power 3. And the new power divides here. Plus 25, we introduce x there. And we divide by the power of x, which is just 1. So it remains the way it is. We can have the arbitrary constant. And now we are integrating from 0 all the way to 5. So can we substitute 5 first? When we substitute 5, it shall be negative 5 power 3 out of 3 plus 25 into 5 plus c. Then we subtract the same function, but having substituted 0. Negative 0 power 3 over 3 plus 25 into 0 plus c, that way. So with this, we need now to talk about negative 5 power 3 divided by 3. Then I add 25 into 5, giving us a 83 and a third. I think, yes, 83 and a third minus 0. So 83 and a third plus a constant minus 0 plus a constant. You know, the constant will cancel. And now I'll be having 83 and a third square units. That is the area bounded by the curve and the axis. Now with that, we can also talk about the area which is here. These are 5 units. This is a straight line, so we can treat it as an hypotenuse. And now vertically upwards, this curve is going to cut the y-axis at 25. Yeah, at 25 there. Therefore, from 0 to 25. So now we can talk about the triangle, which is unshaded. Triangle O. This point can be called Q, OQP, or OPQ. Half multiplied by a base of 5 and a height of 25. What area does this one give us? Let me check. Half by 25 by 5. This is giving us 62 and a half. 62 and a half square units. So now I need to get 83 and a third. Then I subtract 62.5. You see, finally I'm getting 20 and 5 over 6. So 83 and a third. Then I subtract 62.5. I'm getting 20 and 5 out of 6 square units. Yeah, square units. So that is the area of the shaded part. I have taken the triangle, which is unshaded. Then I'm subtracting it from the whole area between the curve and the axis. So that is it. So we work around such a question. Number 11. Today we are going to finish the whole section 1. We shall finish the whole section 1, which is a very interesting paper, very interesting section 1. A quantity A is partly constant and partly varies as the square of n. So this is partial variation, in other words. Given that A equals to 11 when N equals to 2 and A equals to 95 when N equals to 5, find the value of A when N equals to 3. Yeah, when N equals to 3. So at this point now, we shall interpret the first statement as a quantity A varying partly constant, and the other part, it varies as the square of N. Square of N. So this is now the interpretation, and we can do away with the symbol of proportionality by introducing an equal sign and two constants. So whenever variation is partial, constants are always two. A equals to a constant K plus, that's partly constant now, and another constant C to multiply N power 2. So A is 11 when N is 2. 11 equals to K plus 2 squared for C. Again, A equals to 95 when N is 5. So 95 equals to K plus 25 times C. So with this, now we have equation 1 and equation 2. Now we can work what we call elimination method. And looking at the two equations, the coefficients of K are already equal. So K can be eliminated in advance. And how do we eliminate? Subtracting equation 1 and 2. So K minus K, that becomes a 0. Then 4C minus 25, that becomes negative 21C. What about 11 minus 95? This gives us negative 84. So the value of C now shall be, the negatives will cancel, and the 84 over 21 becomes negative 4, or becomes 4, sorry. The negatives have cancelled. So the value of C is 4. What about the value of K? We now get the value of K, so that you may get the equation that relates the two quantities. All right. Okay, 11, according to equation 1, equals to K, which is unknown, plus 4, the value of C, which is also 4. Therefore, K plus 16 equals to 11. The value of K shall be 11 minus 16. We get a negative 5. Yeah, I hope I'm right there. Negative 5, very true. So the original equation now, which is here, can be rewritten as a specific equation. A equals to a constant K plus a constant K, which is a C, which is 4, N power 2. This is the general equation. No, the specific equation. This one is the general equation. So we are having now the specific equation that connects the two constants, the two quantities, sorry. Find the value of A when N equals to 3. Negative 5 plus N into 3 squared, because N should be squared. The value of A shall be, when you compute this, you shall get 31 positive 31 that way. So that's a very good working. Remember, ladies and gentlemen, you can reach out to us through the number 07 04 15 33 66 for consultations and also for you to acquire the learning resources for mathematics and physics. So feel free to reach out to us through the attached number on the board. Number 12 now. The figure below shows a circle, center O, which is a 1, 1. The coordinate is 1, 1, which passes through a point Q, which is 3, 6. Determine the equation of the circle in the form x squared plus y squared plus ax plus by plus c equals to 0, where a, b, and c are constants. All right, constants, not necessarily integers. You know, people have to be very careful with this kind of instructions. You've been told constants, so they can be fractions, decimals, or even integers. But now there are cases like in number 1, where we were solving a surd, and we had been told this surd must be The surd must be the surd must be the constants that we were supposed to leave them as integers. So integers are different from constants. Though you should know that integers are constants, but not all constants that are integers. Okay. Now, from the center to the point on the circumference, we can get the circumference, we can get the radius of this circle. So that's a radius. So how do we get the length? We need the units on the x-axis, the change in the x-axis here, and also the change on the y-axis here, so that we may get the radius. So x is changing from 1 to 3. That means there are 2 units here. Y is changing from 1 to 6. So there are 5 units here. And with this, we can use Pythagoras theorem. From 1 to 6, there are 5 units. From 1 to 3, there are 2 units that way. So we can use now Pythagoras theorem to get the R here. Yeah. So R squared should be given by R squared should be given by 2 squared plus 5 squared. So from this, we can say R squared equals to 4 plus 25, which is a 29. So the root of 29 becomes R squared. Or 29, sorry. R squared is 29. You're also supposed to know that the equation of a circle is given by, generally now, remember this is R squared, not R. I've not found R. I've found R squared for specific reasons that I know, because we are dealing with a circle. Okay. X minus A, which is the x coordinate of the center, squared, plus y minus B, which is the y coordinate of the center, squared, should give us radius squared. That is the general equation of a circle when the center is not 0, 0. So x minus 1, according to the center, squared, plus y minus also 1, because the coordinate of the center is 1, 1, squared. This is supposed to give us radius squared, and radius squared is 29. Yeah, radius squared is 29. So instead of taking square root for me to start squaring again, I've remained with r squared. Let me expand now. X squared plus 2, no, minus, sorry. We are squaring. These are quadratic identities, negative 2x, then plus 1. Then we add y squared minus 2y plus 1 equals to 29. Look at the format that we are supposed to arrange the equation at. So we start with x squared. We add y squared, then negative 2x, then plus, no, minus 2y also, then minus 2y. Then now at this point now, we shall have 1 and 1. 1 plus 1 minus 29. We get negative 27. So that now we are having a 0 on this side. Yeah, so that we have a 0 on that side. That way. You see? So this is the equation, and we have arranged everything. We've arranged everything in the format that I needed it. Okay. Let's look at number 13 now. Very interesting question from commercial arithmetic. We are told that Orinki bought a mobile phone on hire purchase terms. The cash price of the phone is 80,000 Kenya shillings. Then he paid a deposit of 8,000, followed by 18 monthly installments of 4,500 Kenya shillings each. calculate the monthly rate at which compound interest was charged. Now, what you're supposed to understand, is that compound interest is usually charged on the balance after the deposit was made. Therefore, the balance that remained after deposit was paid, balance on the cash price after deposit is made, is what will be paid at a rate. So we can say that our principal is the balance. Our principal shall be this balance now, which is 80,000 minus 8,000. You write it very well. This gives us 72,000. I hope that is so correct. Now, after this balance remained, what did we end up paying? This now we call it amount. Instead of paying a balance of 72,000, this gentleman called Orinki ended up paying in 18 months 4500. So we will have 18 by 4500, 81,000. Yeah, so we are having the amount and we are having the principal. So now we can find the rate by saying that amount when interest is compounded is usually given by principal into 1 plus a known rate of 100 raised to n, the number of interest periods. Therefore, we can talk of 81,000. This is equal to 72,000 into 1 plus rate unknown of 100 raised to 18. That's simple. Raised to 18. Can we take 81,000 divided by 7200 and we get 1.125? Now this is after dividing by 72,000 through. This now is 1 plus rate over 100 raised to 18. Because the right hand side raised to power 18, we can now obtain the 18th root. 18 shift power of 1.125. This gives me 1.00665, yeah, for significant figures. And this is now equal to, after getting now the 18th root, this is 1 plus r over 100. So we can remain with r over 100 and we subtract 1 so that you have 0.006565. The value of r is going to be, to subtracting 0, then we multiply by 100 through, and this shall give us 0.6565% to 4 significant figures. So this is the monthly rate of compound interest according to the deal that Oringi entered into. So that is it. A very simple question, but learners are supposed to understand interest is usually charged on the balance, not on the cash price. So the interest is being charged on a balance of 7,200. That is why we are ending up paying 81,000 after 18 months. So the rate of interest can be computed that conveniently. Okay. Now with this, we can proceed to 14. Very interesting question again. In 14, we are told that the weights of 6 boys in kilograms are 10, 11, 12, 13, 14, and 15, while those of 6 girls are 8, 9, 10, 11, 12, and 13. A boy and a girl are picked at random, and the sum of their weight is added. Sum of their weight is added, or yeah. The sum of their weight is recorded. Draw a probability space to show all the possible outcomes. So let me show you how a probability space is usually drawn. You can have a column there for the boys, then a row for the girls. Note there are 6 in both cases. There are 6 in both cases, so we're supposed to be very careful. 6 in both cases. So we can have 1, 2, 3, 4, 5, 6. So we can have let me write the boys here. Then after writing the boys there, then the first boy is having 10. The second boy is having 11, 12, 13, 14. And the last one is having a weight, not actually a weight, but a mass. I think there is a misuse of language there. In kilograms, we record masses. Okay. Now for the boys, we have recorded. Let's look about the girls now. The girls are also 6 girls. Let me do the columns for the girls. 1, 2, 3, 4, 5, 6. So here we can talk about the girls, the girl child. So girls are here. The masses of girls, which are, the masses. These are masses, not weights. Okay, 8, 9, 10, 11, all the way to 13. 8, 9, 10, 11, 12, 13, that way. So when we pick a boy and a girl, we are adding them to this. It's random. So we can pick 10 and 8. A boy having a mass of 10 and a girl 10, 8. So that we get 18. Then the same boy can be picked with a girl of 9, so that we get 19. Then we proceed. We just add. We continue adding the value. After that, we say again, we can pick a girl, a boy having a mass of 11 and a girl having a mass of 8. So that this becomes 19. Then we have the next 11 and 9 giving us 20, 21, 22, 23, 24. Here, 12 and 8, 20, 21, 22, 23, 24, 25. 13 and 18, 21. The next should be 22, 23, 24, 25, 26. 14 and 8, 22, 23, 24, 25, 26, 27. I'm adding everything. 14 plus 13, 27 that way. Then 15 plus 8, 23. 15 and 9, 24. 15 and 10, 25. 15 and 11, 26. 15 and 12, 27. 15 and 13, 28 that way. So we have all the possible additions now here. All possible additions. Total of 36 possible outcomes in blue. So the outcomes are in blue that way. Part B of this, find the probability that the sum of their weights, which these one two masses, the sum of their masses is at most 22 kg. At most means can't go beyond 22. So 22 and below, in other words, 22 and below, 22 and below. So probability mass being either 22 or below 22 or below. So the options are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I don't know whether there is something that I've not counted. So this is a 15 out of a total of 36. We can divide by 3 to get 5 and by 3 to get 12. So this probability is correct according to the interpretation, but mathematically it's good to simplify that way. Yeah, I think we are doing it well. We are in number 15, almost winding up with the section 1. Given that the values of x are ranging between 2 and 6, and remember 2 is included and also 6 included. That means these are the maximum limits, maximum and minimum respectively, 6 and 2. The values of y are also ranging between 8 and 12, up to a maximum of 12 and a minimum of 8. Find the limit of working out this quotient. The limit of working out this quotient, that means we need the range, the maximum and the minimum. So let's get maximum. We start with the minimum, okay? Let me get with minimum value of this. For me to get minimum, and I'm dividing, minimum quotient, we are dividing, minimum quotient. It requires minimum numerator out of the upper limit of the denominator. For us to get a small quotient after dividing, we need to use a very small numerator, but a big denominator. So we need the lower limits. We need the least sum, in other words now, because the numerator is addition. The least sum shall be, for x we pick 2, and for y we pick 8. Divide by the biggest denominator. And the denominator is a difference. How do we maximize a difference? How do we maximize a difference? To maximize a difference, we use lower limit for the first value and upper limit for the one that we are subtracting. So I'll be talking about 10 over 2, which is 5. Yeah, 10 over 2 is 5. Yeah, for me to get maximum difference. I think I've not picked well. For me to get maximum difference, I need the biggest value, but I subtract the smallest. Yeah, the biggest value, but I subtract the smallest value on the other side. So the biggest value of y, but I subtract the smallest from x for the difference to be so big. I hope that language is being understood. So we are talking of minimum quotient, which requires a small numerator and a big denominator. Then we ask ourselves, how do we get, because we are adding on the numerator, how do we get minimum sum? Minimum sum means we add upper limits. We add upper limits. For us to get minimum sum, we add lower limits, sorry. We add lower limits. Lower limits. That's why I took 2 and 8. I'm getting 10 from that. Divide by, now on the denominator, which we need it to be maximum. We need maximum difference because it's a subtraction. Maximum difference, we take the biggest value. So upper limit minus the lower limit of the second quantity. When we take the upper limit in y, which is 12, and we subtract the least value of x, which is a 2, then we get the maximum difference. So maximum difference in this case is now going to be 10. So I'm getting 1 in this case. Then I proceed and ask myself, that one now is the minimum quotient. What about when we want to work out maximum quotient? See? Maximum quotient requires for us to get a very big value after dividing. We need maximum. You write it well. I'm looking for maximum quotient. So I need maximum numerator, but this one should be divided by minimum denominator, the smallest possible denominator. So what will be the maximum numerator? Now, being a sum, I need to add all the upper limits for me to get maximum sum on the numerator. You know, these are sum. So for me to get maximum sum, I need to add upper limits, and that is 6 from x and 12 from y, divided by, for me to get the least denominator, which is a difference, I need the least difference. And for me to get the least difference, I need to get the lowest value in the second part, which is 8, minus the maximum on the other side, which is a 6. So I'll be having 18 out of 2, and this giving me 9. So maximum quotient is 9, minimum quotient is 1. So if this was being calculated as P, for example, then P is ranging between 1 and 9. Between 1 and 9. So the range, or rather the limits of the expression, which I'm letting it to be P, is going to be from 1 all the way to 9. Those are the limits. And that is from errors and approximations. Now number 16, a very good question from a 3-dimensional geometry. The figure below shows a box of milk, A, B, C, D. Given that M is the mid of CB and AB equals to AC, and the value is 6.5 centimeters, just as you can see according to the diagram, and that the perpendicular height AD is 54.4 centimeters. That one has been given clearly. Then what are we finding? Find the angle between the planes DBC. We can see the plane is here. And ABC, which is the base. Give your answer to 1 decimal place. So for me to get the angle between two planes, then I'm supposed to consider their line of intersection first. So ACB, okay, ABC together with DBC are meeting on line CB. So they share line CB. Therefore, I draw a parallel line to the line that they share from each of the planes. From the first plane, I've drawn a line to the line of intersection. And from the second plane, which is the base, the line had already been drawn. So where they are meeting now, that is the angle we need. So we need the angle DMA, angle AMD. That is what we are looking for. That will be the angle between the two planes. I hope I have outlined that angle very keenly. So we need theta. Now, for me to get the value of angle theta, then I'm supposed to be having some lengths here. We need the length from M to B. Remember, M is the mid. Therefore, 11.2 divided by 2, this is giving us 5.6. So the length here is 5.6. And we are also having another length here of 6.5. So with that knowledge, then we need to work out, this is now right angled because because AM is bisecting CB. So it cuts at M through a perpendicular angle. And therefore, we can use 5.6 and 6.5 to get the angle, to get the length from A to M. In other words, let me outline what I'm talking about. Let me just use diagram so much in this case. The line, this one, then from M to B, and now we're having a line through here. So I've gone to the base and I've splitted it to M, B, so that this is 5.6 and this one is 6.5. So with this, and we said that from A to M, it was perpendicular, then we can use Pythagoras theorem to get the length AM. So the length AM will be given by, when we take 6.5 squared and we subtract 5.6 also squared, then we take the square root now. Take the square root. So the length AM shall be 6.5 squared minus 5.6 squared, then the square root now. Exactly 3.3 centimeters. So the length through there, 3.3 centimeters. Now, if that length is known, and also the perpendicular height AD is also known to be 54.4, then the angle at D can also be found. With reference to this angle, we are having the opposite length and also the adjacent length. This one, because we said perpendicular height, that means we have a right angle at that point. And this can lead us now to using a trigonometric ratio, and the most preferred shall be tangent. Yeah. So the tan of this angle, will be given by opposite out of the adjacent length. Yeah. Opposite of adjacent, which is 3.3. So now with this, then the theta itself can be found. That means we pick the tan inverse of 54.4 over 3.3, and this will give us the angle. We must ensure that it is to 1 decimal place according to the instructions. So I'm taking the shift tan of 54.4 out of 3.3, and this is 86.53. 86.53, but now to 1 decimal place, we will get 86.5. Yeah, 86.5. So that is it. Thank you so much for following up with section 1. Later, we'll be meeting for the section 2 of the same paper. Remember, you can support our programs using the till number attached here, 497772. Any amount is going to be highly appreciated. So thank you so much. See you next time.